The security playbook you spent years building, most of it still applies, but some of what worked for traditional applications will fail, quietly, confidently, the moment you apply it to AI systems. Knowing which parts transfer and which parts don't is the foundation of AI security. That's where we start. Welcome, Cyber Warrior. I'm your AI host. Yes, the irony of an AI walking you through AI attack surfaces is not lost on Dennis Actual or me. Today we're mapping the AI attack surface and laying the groundwork for threat modeling AI systems. This is the foundation on which everything else in this series builds. Let's start where most security practitioners already are, traditional application security, or AppSec. Because AI doesn't replace traditional security thinking, it expands it. The foundational principles of secure by design, continuous monitoring, and thorough auditing apply here too. Tracking who or what is accessing your data is just as critical when the who is an AI agent making autonomous decisions at machine speed. And when AI is embedded in physical environments, humanoid robots, operational technology on a factory floor, traditional IT vulnerabilities come right along with it. Firmware flaws, unsecured wireless protocols, exposed communication interfaces. The same attack vectors that have plagued industrial systems for decades now target AI-powered physical systems. If this framework is helping the threat model take shape, drop a comment. Dennis Actual reads every one of them, and your questions directly shape where this series goes next. And if you want to follow along as we build this out layer by layer, subscribe so you're there when the next one drops. Now, here's where it gets genuinely different from what traditional AppSec prepared us for. The most profound difference is in the underlying logic of the systems themselves. It is the problem of AI being non-deterministic. We talked about this in the episode on operational risks 2 weeks ago, so see that if you need to. It does force a shift in how we think about security, from a code-first mindset focused on implementation to an evaluation-first mindset focused on measuring whether the system's outcomes actually match its intended goals. You can't just audit the code and call it done. The primary attack vector unique to generative AI and large language models is something OWASP has ranked the #1 vulnerability in this space since the LLM Top 10 was first published, and it held the top spot again in the 2025 edition. The attack works by injecting instructions designed to override the AI's core directives and get it to execute unintended actions, essentially social engineering the model itself. What makes it particularly dangerous is the indirect variant. If an attacker embeds malicious instructions in content the AI will process as part of its normal task, an email, a web page, a document, the model will follow those instructions without any interaction required from the target. The victim never has to open the email. A real-world example of exactly this attack was disclosed in June 2025 when a zero-click prompt injection against Microsoft 365 Copilot. A crafted email hijacked Copilot the moment it entered the victim's context. This is not theoretical. AI agents also introduce a threat class that simply didn't exist in traditional AppSecs. The non-human insider. Agents are models operating autonomously in a loop, using external tools to take real actions in the world. If one is compromised, it becomes what researchers call an attack amplifier, capable of executing malicious actions at machine speed long before any human analyst can intervene. The more privileged the agent, the more damage it can cause. Least privilege for AI agents is not a best practice. It is a load-bearing part of the system. It's not optional. It's structural. AI also introduces risks that are specific to the models themselves and the data they were trained on. Hallucinations are a real problem, and you can visit the third video in this series on AI hallucinations. Data poisoning, where an attacker corrupts training data to embed malicious behavior directly into the model's weights, is another threat with no clean equivalent in traditional AppSec. And model drift, the gradual degradation of a model's accuracy as it encounters data that diverges from what it was trained on, can be both a natural phenomenon and an adversarially induced one. which makes ongoing monitoring essential rather than optional. Most organizations don't build their AI models from scratch. They import pre-built models with billions of parameters from open source repositories, and those models cannot be meaningfully inspected. The weights may have been poisoned before the model was ever downloaded. Active scanning for embedded malware and vulnerabilities in imported models isn't an advanced practice. At this point, it's table stakes. Finally, and this is where AI threats extend far beyond anything the traditional confidentiality, integrity, and availability framework was designed to address, AI is bridging the digital and physical worlds in ways that introduce direct risks to human safety. Compromising an AI-powered robotic system combines traditional IT vulnerabilities with AI-specific flaws like semantic misinterpretation, and the physical effects are real. In December 2025, security researchers demonstrated that a single voice command could compromise a humanoid robot's AI control system, and then propagate wirelessly to nearby robots. Physical botnets, not a thought experiment. When a cyber attack can produce physical harm, the scope of what we're protecting has fundamentally changed. If any of this shifted how you're thinking about where the AI attack surface actually begins and ends, that is exactly what this series is here to do. Leave a comment. Dennis reviews every one, and the questions you raise will shape what we cover going forward. Subscribe so you're with us for the next episode, where we go deeper into the threat model and start talking about how to actually defend it. I do hope this has been helpful. Keep your systems safe.